Hello everyone, this is Dr. E and I'm going to share with you how I encourage my students to be able to practice correctly when they are working with derivative functions. And whenever my students are asking me how to be good in mathematics and how to be able to gain confidence when working with calculus problems, I always tell them to practice because we know that practice makes perfect. But the challenge is sometimes when we are doing complicated derivative rules and trying to practice on our own, we need to verify if what we are doing is correct. And sometimes our teachers or our friends or sometimes the problem in the books is not really helping us to be able to see if we did our work correctly. And that is what I'm going to be sharing with you, how to use technology so that we would be able to practice with confidence when we're working with derivatives of a function. So for students, we have videos on derivatives that you can practice on in the description box below. And for teachers, use them and share with them and maybe let them use technology to be able to appreciate calculus better. And to be able to do that and to be able to appreciate calculus better, you need to know how to solve derivatives of the functions analytically and graphically. And analytically, this is when you need to memorize and apply the many derivative rules that we have by hand so that we'll be able to know the processes and procedure and how to find the derivative of a function. It could be using the power rule, quotient rule, chain rule. Sometimes we need to know some complex rule for ln function or logarithmic functions or trig functions. And once we know how this rule works, we can verify it by looking at the graph of our derivative functions. And this is where Desmos is going to come into play. So I'm going to show you how you're going to use Desmos or technology in making sure that your answers and how you use the formula or derivative formula is correct by using technology. And these are some of the examples that I'm going to be working on. And we know that some of them are easy, like problem number one, and some of them can be a little bit complicated, like this function right here, 5 raised to e raised to 2x. So for the first problem, finding the derivative of this function is going to be simple because we're just going to use power rule to answer this. And to do that, we know that the derivative of 2x cubed is 6x squared. Plus, we know that the derivative of 7x squared is 14x. And we know that the derivative of 8x is the constant 8. So this is our derivative function for problem number one using power rule, which is pretty simple and pretty basic because it's just a simple polynomial. Now, how about finding the derivative of 5e raised to 2, 5 raised to e raised to 2x, or a to the u, constant raised to a power. So to be able to find the derivative of a constant raised to a power u, the formula for finding the derivative of this function is a to the u times ln a times du dx, or the derivative of the function u with respect to x. So to be able to use the formula, a to the u is simply 5e to the 3x, so we're just going to copy that. 5e to the 2x multiplied by ln of a, which is ln of 5, times the derivative of the function u, which is e to the 2x, so the ddx of e to the 2x, we know that the derivative of e to the 2x is 2e raised to 2x. That means we're able to find the derivative of 5 raised to e to the 2x by 5 raised to e to the 2x multiplied by ln of 5 multiplied by 2e to the 2x. So the challenge here now is, did we use the formula correctly? And some students may doubt their answer. So what we're going to do is we're going to be using Desmos to be able to verify if our answer is indeed correct. And to be able to use this hack, let's type in or plug in the answer that we got from our manual calculation. So the derivative of 5e to the 2x is 5e to the 2x, 5 raised to e raised to 2x multiplied by ln of 5 multiplied by the derivative of the u function, which is 2e2x, not like that, 2 raised to e to the 2x. Yeah, there. E to the 2x, e to the 2x. So this is the graph of our answer. So this is the derivative graph. But the question is this the correct answer? And to be able to do that, all we need to do is to graph the derivative or the questions in our derivative function, which is the ddx, or the derivative with respect to x, of 5e raised to 2x. And we are simply going to copy this, Control C, and enclose it in the parentheses and paste it, and you will see that it just changed the color of my original graph. And that change of color is basically verifying that your answer is correct, because this is your answer when you find the derivative of a to the u manually, and the red graph is the answer using Desmos. And you can see that they are the same graph because both your answer based on the formula is correct from the function that we have with Desmos without working out the formula and just using the ddx as our command. So this is how we know that our answer is correct, and this is how sometimes it's a lot easier to work with functions like what we're doing here right now when we know how to use technology. And this will give us more confidence when we are answering problems involving derivatives. So however, or your function may be as complex as problem number 2 or as easy as problem number 1. And if you want to make sure that your answer is correct, you can use Desmos to see if you're able to use the formula correctly. And this is how we are working on problems involving derivatives so that we can gain confidence when we're working with math problems similar to the derivative of the function. So 2 things: you need to know how to answer your derivative problems analytically, and you also need to know how to do that graphically so that you'll be able to use technology to see if your answer is correct. And for teachers, you want to share your technique and strategy on how to engage your students and have them master the derivative rules, comment it down below, and we'd love to hear from you. And for students who are mastering their skill on finding derivative functions, the problem sets or some of my videos are in the description box below that you can work on. And again, you just need to learn how to practice correctly and making sure that you are understanding how to use technology for it to work for you. Because technology, you can use that. You don't necessarily cheat when you're using technology. Just make sure the math behind the answer that you are getting from Desmos so that you will understand why certain formula is working like so. This is Dr. E, and see you again next time. Bye!